Hey guys, it's Mr. Hing here. I hope you're all well. What we're going to be doing today is kind of like another part of exponents, not another part, but another set or part of questions on exponents. Okay, so what I have today, if I zoom out, you'll see that I have about seven. Did I miscount? One, two, three, four. That's supposed to be five, six. So I have about six questions for us today. And yeah, I'm going to take us through the different steps on how to do it. So why don't we jump right in? Okay, let's have a look. I think that's a bit too close. Right, guys. So let's have a look at question one. So we have a bracket, a to the 5, b to the 2 close bracket, and we have a raised to the power 4. Now remember, when we have an exponent on the outside of the bracket, it affects everything. So that includes the 5a, 5 to the a, and the b to the 2. So the 4, the power 4, will affect everything inside of the bracket. So that means it's going to affect this and this. So now remember, guys, that what is the rule if I have an exponent, let's say for instance a to the 3, raised to another exponent? What's going to happen is my exponents will be multiplied together. So that means that this 4 is going to be multiplied with the 5 and the 4 will be multiplied with the 2. So this is how it actually looks. So if we go over here, it will become a to the power 5 times by 4, and then the b to the power of 2, the 2 comes from here, times by the power of 4. And that is going to equal our answer of a to the power of 20 and b to the power of 8. Okay, so I hope that's helpful. Let's carry on and look at number 2. So number 2, we have a bracket, and there's 3, a to the 2, b, close bracket raised to the power 4. And again, remember, this 4 affects everything. It affects the 3, the a squared, and the b. So let's see how it affects it. So firstly, remember what we know, that's the power of the exponent of the 3. There's an imaginary 1 here. So remember, we're going to say 1, the imaginary 1, times by 4 coming from here. And then the a, it's going to be 2 times 4. And then the b, there's an imaginary 1 again over here, imaginary 1. That's why I wrote 1 over there. And we're going to multiply it by 4. And then our simplified answer, please look what I said here. I said leave in exponential form. So they want our answer to be left with answers that have exponents. So it's going to be 3 to the power 4. I don't do 3 times 3 times 3 times 3 and put that answer there, because they want it in exponential form. And then it's going to be a to the 8, because 2 times 4 is 8, and b to the 4, because 1 times 4 is 4. And that's my final answer. Okay, let's have a look at number 3, guys. This one is a little bit different, but remember, it's saying leave in exponential form. So there are two ways of doing it, guys. That's why I put a or word there. So the first way of doing it, guys, is if you say, okay, I know the rule over here. Let me just do an example. So if I have a to the power of 3 times a to the power of 2, we know that we need to add the exponents. So it will be the 3 plus 2, which will give me a to the 5. And when I end up dividing, what do I need to do? I need to subtract. So let's have a look at what we need to do here. We are timesing, and then we are subtracting, and it's the same basis, 2, 2, and 2. So let's see how we do that. So we're going to take this exponent, 4. Let me just get my laser. 4 over here, 4, times, so we're going to plus the 5. And then when you divide, you're going to subtract 10. Okay? So now what happens is, it's 4 plus 5 is 9. And then we need to subtract 10. But now what happens is 9 minus 10 is minus 1. So have a look at what happens over here when you get to this point over here. Is that, guys, we're going to get a base of 2 with the power of negative 1. Now, guys, there's a rule in exponents. I've done it in another video called exponents. I think it's called negative exponent rule. But I'll just quickly explain it now, that if you have a negative exponent, they would want you to simplify it and leave it in its most simplified form. And how you get, and that is getting rid of this negative exponent. So how do we do that? Well, what we can do is, if you have, let's say for example, a to the negative 4, this is the same as writing 1 over a, and then this becomes a positive 4. So that's a rule in exponents. Okay, so that's why what ends up happening over here is this negative 1. This base of 2 is going to become a denominator. Can you see that? So this is going to be 1 over 2 raised to the power of an imaginary positive 1 over here. Okay, the other way of doing it, guys, is that if we know that it's 2 to the power of 9 at the top, 4 plus 5 is 9. And then remember, we can write divide by 2 to the power of 10 like this. We can write a division line like that. And then this is nice and easy, because if you cancel the 2's out, you will have 1 2 left at the bottom. So it'll be 1 over 2 to the imaginary 1. Okay, so those are the two different ways. Maybe this way is simpler for you. Let's have a look at number 4. Now, number 4, guys, it's color-coded. There's a reason why I did that. So, firstly, because when you get a question like this, you need to make sure that you do 2 important steps. I always teach my learners, the first step is you deal with your coefficients, and then step number 2, you will deal with your variables. Okay, well, the respected variables. So let's have a look here, or the specific variables. So what's going to happen is I'm first going to deal with my coefficients, which is 5 and 6. So I'm going to say 5 times 6, 5 times 6. Then I'm going to deal with my variables. So that's going to be a squared times a cubed. So what happens when I have the same bases? I add my exponents. So it's going to be 2 plus 3. Okay, and then for my b, it's b to the 5 times, it's going to be the same thing. There's an imaginary 1 here. So it's going to be 5 plus 1 from this 1 over here. And then when we simplify it, we're going to simplify the 5 times 6 is 30. A to the 2 plus 3 is a to the 5. And b to the 5 plus 1 is b to the 6. And that is how I get that answer. All right, guys, let's have a look at my last 2 questions. Let me just erase that, because this is supposed to be number 5 and number 6. Okay, let's have a look here. So number 5 is a little bit more intricate and detailed, so let's have a look together and do it slowly. Firstly, guys, it says leave in exponential form. So let's have a look at the question first, right? I have a division line, right? I have a bracket, 2a to the 2 close bracket squared. So this, remember from the first question, if I have a exponent on the outside, it's going to affect everything on the inside. So we need to keep that in mind. Then we need to keep in mind that it looks like we have the same bases all over here. The base of 2. So let's keep that in mind as well. And let's simplify this part, and we can go on and see how we can answer it together. So I'm going to simplify this, remember. So this 2 on the outside, the exponent is going to affect this 2. So this becomes 2 to the power of 2. Now, guys, please remember, do not write the 2 to the power of 2 as 4, because we know that 2 to the power of 2 is equal to 4, but it's asking us to leave in exponential form. So that's why we should leave it like this, 2 to the power of 2, because that's the exponential form. And you'll see how it gets simplified further just now. So then over here, it's 2 times 2, so that's how I get that. And then I've just left this the same, times 2 to the 3, 2 to the 3, and divided by 2, divided by 2. Now let's see how I simplify it. How did I simplify it? Well, if you look at the top line, we have the same base over here. Let me just get a color. We have 2, the base of 2, the base of 2. So doesn't that mean when I have the same bases, and I'm multiplying, I can add the exponents. So that means it's going to be the 2 plus the 3 over here. So 2 plus 3. And then we're going to simplify my variable. So it's a, and 2 times 2 is 4. So that's where I get the 4 there. So now what happens is I can simplify this. So this is going to equal 2 to the, let me just erase this because it looks a bit messy, and then I'll explain what I did afterwards. So I'm just going to do it with you. So this would be 2 to the 5 because 2 plus 3 is 5, and then it's over 2, which comes from here. So now, guys, how do I simplify this? Well, remember this 2 has a 2 to the imaginary 1, and it has the same basis. So if I am dividing, I can cancel, and there will be 4 left, 4 2's left over at the top. So that's going to leave me with 2 to the 4 and a to the 4, like that. Okay, right, let's have a look at my last one, number 6. This one is very interesting because we need, this is a different method, not method, but a different rule, and we need to know how to apply this. So let's have a look at this question. It says, remember the cube root, that's very important, the cube root of a cubed and b to the 27. Now, guys, when you get a question like this, what happens is that your exponent, please listen carefully and make notes. Your exponent, look over here, I drew a line here, or an arrow. Your exponent, the 3, is this 3. This 3 is this 3. And you're saying, Mr. Hing, why are you dividing by 3 over here? Well, what happens, look at this green line, it comes from here. So what's happening, guys, when you get a question like this, your exponent, when you're simplifying, your exponent gets divided by the number on the outside of the root sign. Does that make sense? Okay, so then this b over here, let's look what happens. The 27 gets divided by 3 because the 3 comes from the outside of the root sign. So let's say, for example, I'm just going to use an example quickly. If we have the square root, remember, if there's no number on the outside, it means there's a 2 or a square. If it's a square root of 8 to the 6, and I need to simplify this and leave it in exponential form, it's going to become a to the 6 divided by 2. Okay, and then essentially it's going to be 8 to the power of 3. So let's carry on and simplify this. So if I have, so this will be a to the 3 divided by 3, and b to the 27 divided by 3, and we simply simplify this. So 3 divided by 3 is 1, imaginary 1 here, a to the imaginary 1, and then b, 27 divided by 3 is 9, so it'll be b to the 9, and that is how I simplify a question like that. Okay, guys, so with all of that being said, I hope that's helpful. A few different types of questions and rules that we went through, and I'll see you in the next one.